We're asked to use the delta y over delta x method from example number 4 in your text to find the slope of the tangent line to the graph of the function y is equal to negative x squared at an initial value of 2. So it also asks you to sketch. So I'm going to do the whole sketch as I work through the problem so that you can see exactly what we're doing. This is, you take a previous class like algebra or pre-calculus, and they discuss all these graphing techniques, and this is where it becomes important to be able to just quickly graph out a function. Now, of course, you can use your calculator, or you can use a computer program like Maple or Mathematica, or even an online program like Desmos to graph this out. But it's really convenient to be able to look at this function and say, you know what, that's a parabola that's centered at the origin that's been reflected along the x-axis. So the actual function, I'm going to put here in blue, looks something like that. Okay. And now what we want to do is we want to find the slope of the tangent line at x equals 2. So I'm going to go over to 2. I'm going to go down. Okay, and that right there, that guy is where we want to find the tangent line. So I'm just going to draw in here in green an approximation for the tangent line. So notice that that has a negative slope. So when we go ahead and we solve this problem, we should get a negative slope as well, right? For this guy. So m should be negative, where m is the value of the slope. Okay, so we need to go ahead and use this definition for for finding the finding this rate of change here. And so the definition that they give us is delta y over delta x. They say that delta y over delta x for the tangent line is given by the function evaluated at the this guy plus a little bit minus the function evaluated at that guy over delta x. So what does this even mean here? Why are they doing this? Well, what they're saying is look, we're going to take another point. I'm going to erase this so I have a little more room here. This is 2, and we're going to go just a little bit over to 2 plus delta x. So that's x naught, and this is x naught plus delta x, right? I'm going to put this in parentheses here, or not in parentheses, in quotations. Now, what they're saying is, okay, this guy hits down here, this guy hits up here. This over here is the slope of this pink line. Let me draw a pink line in here for you. Right there. And then what they're saying is, okay, at the very end, we're going to let this distance right here in between the two of them, so this distance, we're going to let that thing become super small. And as we do that, that takes this point and pushes it up the line towards this point right here. And when they're super close to one another, those 2 points, we get a really good approximation for this. In fact, if we let delta x go to 0 using what we're going to call limits in the next section, they become exactly the same. And so we get a perfect representation of that green line. So how do we do this? Well, we got to figure out what our initial point is. Well, our initial point is 2, so let's plug that in there. So that's f at 2 plus delta x minus f at 2 over delta x. Now we don't know what delta x is, we just know it's a super small number, like 0.000001, okay? It's actually smaller than that, right? So what we're going to do is we need to take 2 plus delta x and actually stick it in the function. So remember, this function up here, I'm going to write it in a different color. This function, f, it's f of something is equal to negative something squared. Right? We do the squaring first, and then we put the negative out in front. So what we need to do is we need to actually take 2 plus delta x and plug it in here. So that's going to be 2 plus delta x squared negative. Now when we take 2 and plug it in, we get 2 squared, which is 4, and then make it negative, because this negative's on the outside. Don't get this confused. Okay, so don't think that this guy right here is in parentheses and that when we square it, it becomes positive. We square first, and then we make things negative. Okay, so this is going to be minus. Now, when I plug in 2, I said I got 4, so negative 4. Again, we don't know what delta x is, so we'll just put delta x down here. So we keep going. Now let's actually square this out. So this is negative 4 plus 4 delta x plus delta x squared plus 4, oops, over, got ahead of myself, over delta x. And so this, when I distribute the negative in, it's going to be negative 4 minus 4 delta x minus delta x squared plus 4 over delta x. And what cancels here? The negative 4 and the positive 4 cancel, and I can factor out a delta x. So I get negative 4 minus delta x over delta x. And that's going to be equal to, now these guys can cancel, and the reason they can cancel, and the reason that I can even put delta x down here at the bottom, is because delta x is not 0. Delta x is just going to get close to 0. That's the point. We're not actually letting it be 0, we're letting it get close to 0. If you're tired of hearing me say that, that's great, because now you're going to remember it. Okay? It's so important that you understand these small details, because that's what makes the math work. Okay, so we've got these cancel out, and this gives us negative 4 minus delta x. Now this would be a secant line. However, because delta x is going to get really close to 0, this guy right here is going to drop out. And all we're left with now is negative 4. So what does it tell us? It tells us that the slope of the green line is negative 4. You know, it probably wouldn't be a bad idea for you to try a different point on here. Instead of using 2, maybe use 3, or maybe use 0, or negative 2, whatever you want to use. Okay? Follow these same steps and see if you can get a slope that looks correct. Now notice, we said we should be negative. I was negative. Find a guy over here. Okay, find its slope. Yeah, it's supposed to be positive. So if you pick a negative value in here and you work it out, I bet you get a positive slope. Okay, so I know you probably already stopped this video and aren't listening more, but if you still are, my advice to you would be to play around with these problems on your own. Don't just try to mimic what I do, because if you do that, you're just going to end up memorizing things, and things aren't really going to feel comfortable for you. It's when you play around with the problems yourself that, when you play around with your own numbers and you see what happens and you do a little bit of investigation, that's when the math really makes sense. I know that takes some time on your part, but it certainly is worth it if you're going to go into physics, engineering, mathematics, or any of those related fields.